Multiaxis 2023 seen some great changes. Let's go ahead and take a look at what these changes are. So deburr has some big enhancements. Deburr can now utilize any tool essentially with a flute. So a flat end mill, a chamfer mill, taper mill, all of them are fully supported now, where previous you only had ball and lollipop mills to use. And here's that flat end mill cutting a big old chamfer on here. Tool center versus contact point, this is going to help calculation. So this will be a new option here for different calculation types, and we'll take a peek at where the downfalls can be and where this can potentially help that out. Tilt relative to reference surface is a new tool axis control. And we'll take a look at this and see where this can be utilized to hopefully tame down some of them rotary reversals and tilt on some features. So we'll take a peek at that. And then unified. If you're not using unified, 2023 you'll probably have to use unified. As you can see in 2022 we had a lot more multi-axis toolpaths than we do in 2023. We didn't lose any. They were just all put into unified. So we took out a long curve, morph, parallel, and we dumped them inside of unified. And we'll show you why unified is great. If you have programmed with parallels and morphs before, when you open the file in 2023, they're going to look a little different. They're going to be called unified parallel, unified morph. They work exactly the same way. Nothing has changed there. They're just going to be named a little different. And why is unified the ultimate toolpath? Part pattern manipulation. I can pretty much get as many patterns out of here that I want in very little time. Efficient cut pattern editing. Super easy to go ahead and change my strategy inside the same toolpath without coming back in and doing a whole nother setup to look at a different pattern. And the nice thing is same layout with the exception of the cut pattern page. What I mean by that is the tool axis control, the collision control, all of that is going to be exactly the same as you're used to. The cut pattern page is changed to give you all of these options now, so we'll take a look at that. Skip hole. Skip hole is a nice option here for a situation kind of like on the screen, and we'll go over this where we have a potential to have some situations where we're going to try to get over some holes. Now we have an option just to turn on skip hole, and that'll give me nice clean fluid motion across them holes. So let's take a peek at this one. So we're going to start with deburr, and deburr always was a pretty darn good tool path, but we were limited to spherical tools. So really, if I wanted to do this chamfer, I could do it, but I'd have to add multi-passes in there. It was kind of an inefficient way to do it. So in this case here, we always went back and we could do a swarf tool path because we can use pretty much, a chamfer mills and flat end mills to do that cut. So I could do a swarf mill across there. But where deburr is really handy is I don't have to pick upper rails. I don't have to really pick a whole lot of geometry, right? I can pick my whole part. I can chain along a curve, and I can just let it go. So in the deburr tool path in 2023, let's start out this way. We're going to go back to our sharp part. I'm going to pick my whole part, which is a real easy set. And then I'm going to go user define, and I'm going to pick my edge that I want to chamfer. So very easy set. Takes pretty much no time to set this up. Now I have the same distance here, constant width that the chamfer actually was, and I'm going to say one cut along there. Now here's where the change is, the tool. You could never use a flat tool before. Now any tool is supported pretty much. So I have a flat end mill here, which we could never do before. And if I just go ahead and green check this, now what I'm going to do is I'm going to get a nice deburr tool path. It's going to put a 45 on there every time. Along this, kind of like the swarf, but I had a lot less to add there for swarf. And if you get a model that doesn't have any chamfers on it, then you don't have to worry about going and putting the chamfers on and then swarfing it. So we can eliminate quite a bit there potentially by just going to the deburr tool path. Now let's say I want to use a chamfer mill. So if I come into chamfer mill, now I got a 45-degree chamfer mill. Now this is going to turn this essentially just like into a 3-axis toolpath. So same toolpath, just picking a different tool. And now since that's a 45-degree tool, obviously my chamfer mill is just going to work along there, in this case, in a 3-axis motion. But if it had tilt or do any movements while cutting, it still would do that. And then the last one here is taper mill. So now we can go and we can utilize a taper mill. This is a 10-degree taper mill. So now if I go and look at the same exact tool path with the taper mill, now I'm getting a deburr tool path here with the taper mill. So it's doing its tilts, its calculations, figuring it out. Doesn't matter what the angle is on the tool, it'll figure it all out for you. So pretty cool. A couple other little enhancements here is in the tool axis control. Down on the bottom here, you can tell it where to cut. 0% is the tip, 100% is the top of the flutes. So if I go ahead and put this at 80%, I'm going to cut more towards my major diameter, which could maybe be better potentially for surface feet a minute in this case. So now my tool comes down. Now I'm cutting at the 80% on that flute. If I went down to like 5%, it would be cutting on the tip, where potentially that could come into play as maybe there's stuff to collide with down here. So maybe I could give it a smaller number and raise that tool up to cut more towards the tip. Now, one thing about that is you just have to watch your surface feet a minute. You're probably not going the right speeds and feeds there potentially for that diameter. So depending on what you're doing, maybe you can utilize that to help out your speeds and feeds, or help the tool not collide with some fixturing or a table or something like that. So good changes there for deburr. So definitely check them out. Tool center point. So I'm going to go and grab just a little section of a part here. And what I'm doing is I want to machine these blue surfaces. So if I look at this here, we'll go in here and we'll look at what I have currently set. So I have the 3 surfaces, and I'm guiding it just about that. So I'm going to follow that guide. Now, the downfall here turns into when I get into a situation where my radius in here is very close to the same size radius of my tool. What happens is Mastercam gets a little funny. It doesn't know how to calculate that because it may be hitting on 2 sides of that ball end mill. So calculation ends. And as you can see right here, right now, I have an incomplete cut. It cuts there and it stops because it sees some collisions there with different sides of the ball end mill potentially. So in 2023, if we expand out from cut pattern and go to machining geometry advanced parameters, there is a calculation type of contact mode or tool center mode. If I go to tool center mode on the same tool path and generate this, I now have a nice clean motion along them edges. So it didn't cancel out my cut midway through. It forced it all the way through there, giving me a nice calculation. So now I have a lot better motion here, and I'm going to get a full cut along there depending on where it is. So tool contact or tool center mode will be a helper for you if you're running into these situations, which a lot of people do run into. People used to lie to Mastercam and say the tool is a little smaller than what it actually was, so it didn't see the collisions on multiple sides of that ball. You shouldn't have to do that now if you go back with this method and try to utilize tool center mode. So try it out, see if it can help you in them odd situations that you do get into. And then Abe here, we'll go down one more here. So Abe is a good example here of this new option in Mastercam. So what I have here is Abe is faceted. So there's facets all over this thing. And when you're doing a multi-axis tool path, depending on how you're cutting it, your tool may want to try to be normal to all of these facets on that face, which can result in some non-desired tool behavior. So if we just go normal to a mesh here, and what I mean by normal to a mesh is I'm just coming in here and I'm just going and saying cut this, be normal to the mesh. My tool axis control is surface with tilt. So I'm just saying be normal to the surface as you're tilting. I got zeros in there. And right off the hit I look at this and I say, wow, I nailed it. I got beautiful cut pattern here, right? This should be good right off the bat. So let's go ahead and backplot this. And let me pause that and rewind. So one thing I want you to pay attention to is the holder and how many times it's going backwards, because that's really going to tell us here what this cut is doing. So I'm entering in here, and not so bad, but notice when it starts to cut that I get swings back and forth. Now what them are going to be rotary reversals, and they're going to also be tilts. Now the more rotary reversals you have in tilts, the worse off you're going to be in your multi-axis machine. You can see this thing swinging all over the place. Pretty darn bad. So we can speed this up a little bit. You're going to see that tool is dancing all over the place, and to make that tool dance like that, your rotaries are dancing, which is never a positive situation. So this is going to work around, and you can see it's all over the board. Not really too smooth. So we said, okay, well, we're going to go and we're going to do a different method here then. We're going to go ahead and we're going to do a clean core programming. Now, clean core programming has been around for a while here. And what you do is you create a clean core in the middle. So now I don't have any of them facets. And what I'm going to do is I'm going to calculate my tool path on that clean core. So if I come down one, you'll see how my tool path motion is nice and smooth. But then I'm going to say avoid Abe's head. So the tool path calculation is really smooth. It's going to follow this shape all the way down, as you can see. But then when we get to there, we're running into some other potential situations here. So here's my clean core. So I'm calculating against that core that was in the middle, and I'm voiding Abe's head. So it has to calculate against there, nice smooth motion, and it's going to follow that pattern down. So when we do this, it looks a lot better. You know, I'm getting pretty decent tool motion. I got a zigzag on, but you can see that it's just back and forth. Pretty decent motion, right? So the motion is pretty nice, but now where I lost out here is I lost out on pattern. Specifically when I get down into like these areas here, can potentially not be the greatest pattern that I want. Maybe I don't want to cut with my ball end mill potentially there. Maybe it's going to cut more on the top or the back side of that ball end mill. So I compromised, you know, cut pattern in this case, but I smooth out the tool path. So normal to mesh, the first one we did, we had a better pattern, but we were reversing over. The second way with clean core is we got the pattern, but now we're not really cutting the way we would want to cut potentially in some of these specific areas. So we have, you know, kind of two tool paths where I want a little bit of that and a little bit of that one. And we don't have really much of an option for that until now. So now in 2023, what we have is we have a new method. So let's go ahead and take a peek at this. So my cut pattern now is going to change up here, potentially a little bit here. So I'm going to pick Abe again as my machining geometry. I'm going to go to Tool Axis Control, and my new option here is Tilt Relative to Reference Surface. It's going to be in the bottom here. What I can do is I can go pick a reference surface to tilt to. So before we picked Abe's head on the first one, it was normal to the surface. So a lot of badness happening there. The second one, we did a clean core, so our calculation was good, but our cut pattern was compromised because it was going about the clean core. So now I can go and say, I want my pattern on Abe's head, but I want my tilts to be relative to a nice smooth surface in the background. So I went ahead and I picked the clean core that I had in the middle. So that's picked. So kind of the main thing here is collision control. We don't use collision control with this. So I got my tilt and I got my cut pattern, and that's really all I set here. So let's go ahead and green check and we'll take a look at this one. So now as soon as we run this, you'll notice that that's a lot smoother motion, kind of going around there. Now what I have is I have a lot smoother motion, and I also have a lot better cut pattern that I actually would want. So I'm gaining, right? We're getting a lot better here. Now there's one other switch in here that can really help a situation like this out. If I go back to my tool axis control, they have smoothing sitting in the middle here. If I turn smoothing on and regenerate this, now we're going to see an even better tool path right out of the bat here by just turning on that smoothing. So this is going to smooth all them sharp transitions out for me and get rid of that much more tilting. So now if I go, now you're going to see it's even that much smoother. Not really getting any dancing now. It's just kind of following around there, cutting Abe's head, but tilting relative to that clean core in the middle, which gives me very nice motion. So this process here is a big helper to potentially, you know, help these rotary reversals. Now, it's good to look at some stats. So I have some stats here. And, you know, the original tool path where the tool remained normal to the mesh had over 1,500 rotary axis reversals. So that's where it was dancing all over the place. The operation set normal to reference surface with smoothing activated only had 80. So the first one had 1,500, the last one had 80. And the stats are sitting there. Tilts versus rotaries. Normal to surface, 745, 836. Normal to reference surface, smooth, went down to 80 and 0. And just normal to the reference, we still had some tilts and rotaries in there, but a lot less, quite a big margin. So you can see the last option there with smoothing turned on, eliminated almost everything, which is quite amazing. And that's going to be that much better of a surface finish in this case. So stats are always a great thing to look at. That one there tells the tail of the tape right there. So definitely take a peek at that and try to understand how that's working and what it's doing for you. And then skip hole. Skip hole's a pretty quick one to take a peek at. And skip hole can be nice, especially bone plates is where this really comes into play for me, I would say. And here's a situation here where I'm just going to do a multi-axis toolpath. I'm going to do these 3 surfaces here. And I'm going to guide it against 2 guides, a guide there and a guide there. Now, as we can see, it gets to a hole, and essentially I have a mess, right? It's trying to jump all over them holes, and I could cover the holes. I mean, there's multiple ways to get around this. But in here, what we have in cut pattern, if we expand cut pattern out again and go to machining geometries, I have fill holes. And if I green check out of there and just recalculate this tool path, we're going to see that, you know, I no longer have a cut in them regions anymore. And there we go. I had that tool path locked. So now we'll get some calculation out here. And now I get nice smooth motion. So I mean, I got 1 entry, 1 exit, and I got smooth transition over all them holes, making all the difference just by turning on one quick little switch there in the parameters. So if you're in them situations, bone plates, little medical parts like this are great for that. Or just skip the holes. You don't have to worry about the holes if you don't want to. So really good option there. And then unified. We're going to talk about unified here. We're going to talk about why unified is great. And we're going to come back, and I'm just going to simplify the process out here a little bit. I'm just going to do this blue surface here that I have. And we're going to kind of talk about why unified is the ultimate. So I'm going to go to tool paths, and I'm going to go to my multi-axis unified. And I'm just going to grab a ball and mill in this case. I'm going to go to cut pattern. Now, cut pattern, this is the only place where it has changed. So this upper half here is the change. So we have automatic. And automatic gives you the options. So as soon as we go to all these little boxes here, we usually have drop downs with different patterns. So machining boundary parallel. This is going to be a parallel tool path taking the boundary of them cuts into effect. So I'm going to leave it this way. I'm just going to go pick blue. And I like the color mask, so I'm going to go and grab my geometry off color. And I'm just going to check my other stuff here. Tool axis control, surface with tilt, collision control. Anytime you're starting a multi-axis toolpath, do yourself a favor and shut all this collision detection stuff off. Start with as little on as you can to get pattern. We're just after pattern off the hit. I'm going to go ahead and green check. And you'll see that I got a pattern right off the bat. That's pretty darn nice, right? Doesn't look too bad. But maybe this isn't a pattern that I'm going after. Now, this is where Unified really shines. Pattern change on the fly. So if I were doing a morph toolpath, let's say, if I didn't like the pattern, I'd have to get rid of morph, come back and maybe do a parallel toolpath and redo all the sets. In Unified, it's all built into the same one. So I can just come back into the parameters here and go back to cut pattern. And I could say, you know what, I want to do a circular pattern. So I can do center parallel, green check. And now I have a new pattern here. So let me shut off my rapids here. And now I have about different pattern, right? I have a circular pattern working its way out. Maybe that's better for, you know, flow of fluid or a hand polisher potentially. Maybe if you need a better pattern, they'll have to do less work or maybe no work at all potentially. Now maybe I don't like that pattern. I can always get rid of these. So I could get rid of it here. I could get rid of it with this option here, or I could go to a curve row. Now when I go to a curve row, now I have some other options. I have parallel, perpendicular, project, and guide. So them toolpaths are hiding in here now. So if I go parallel, I can go and pick a parallel line. So if I go and say I'm going to be parallel to that, green check, essentially I get a back and forth, a parallel toolpath. Maybe I didn't want that one. I can just come back into the pattern and I could say, you know what, go to a perpendicular, and that's going to shift the cut 90 degrees. So as you can see, as we're starting to go through these, it really gets pretty cool on how fast you can do this. We also have guide. So if I go to guide and green check, now I'm going to be guiding about that. So that's pretty much a parallel toolpath in this case. But if I want to guide against something else, I could always come in here. I could get rid of that guide and I could go and pick another one. Maybe I pick that. Green check, regenerate. Now I'm going to guide about that. So now I'm getting that pattern coming out from there, which, you know, once again, maybe it could be better for specific situations. Maybe potentially collision detection on some of these. So many different reasons to be changing pattern. If I add another curve row, this opens up and now morph is in there. So you won't get morph until you have at least 2 curves in the list here. But if I go to morph, now I could go ahead and I could pick maybe this outside red here. And once again, I have colors on here. So I'm going to morph from that shape. And I come in here and I click this. And now I can pick my second one here. Turn off my color mask. And maybe I'm just going to morph about that guy there. And if I just green check, now I have a morph from the outside shape to the inside shape. So it's echoing out from both and meeting in the middle there. So now I have a little bit different shape potentially there. And there's your morph option. You know, some other things we'd have here if I get rid of them. And maybe I come back and do a guide again. And maybe I'm going to, you know, guide from that shape there. I could also give it containment too. So I can come in here and user defined. And I could contain the cut inside of there. And, you know, maybe if I change my step over a little bit smaller, now I maybe could differentiate that little icon in there compared to the other cuts. So I'm guiding about that shape. So now I'm getting a guide from the outside shape all the way to the center, which is kind of cool. Other options in here would be surface sets. If I go to surface, now I'm guiding about a parallel guide or flow lines now. So flow lines are going to go flow against the U and V. Where these come in, it's potentially like a pinion shaft and stuff like that, where you have nice flow lines along them features. Otherwise, if I guide this, now I can go and I can pick surfaces. So I could go and just pick surfaces off my screen if I wanted to guide about them. And then if I green check, now I'm going to get this pattern here. Now, the problem with that one, I can tell right away, is I left my containment on. So I I need to come back, and to see this, I'm just going to go ahead and go back to automatic, and we'll crank this up a little bigger so we can see it quicker. And there's my pattern off of a surface. So surface works a lot like edge. It just gives you the option to pick different features there. And like I said, you have guide, parallel, flow lines in here for surface sets. So that would be one of the main changes for that. And then you do have some plane settings here as far as WCSs, construction plane, custom angles that you could machine at. That would give you different ways to cut this on plane rows, if you would. So as you can see with Unified, I just showed you how many different patterns by utilizing these options here in very little time in the same tool path, so I don't have to go back and reset everything. And now I could go back into my collision control and start adding that stuff to get some tilt into them features to avoid collisions. So just a general rule of thumb there is anytime you're using multi-axis, get your pattern down first and then start adding on collisions, detection and avoidance and all of that. You'll be a lot better off as you move forward. So definitely keep that in mind. And that should be it for multi-axis. You know, and any questions with any of this stuff or Mastercam in general, make sure you give us a call. Our phone number here is 952-361-5598, and thanks for watching my video.